Close your eyes now, and let yourself drift upward, up beyond the ceiling, beyond the clouds, beyond even the pull of Earth itself. We're going to take a journey through the gentlest corners of the cosmos tonight, where time moves differently and everything is vast and patient and calm. Let's begin with something comforting, the light that's touching your eyelids right now, even in darkness. Every photon of light that has ever reached Earth from the stars has been traveling for years, sometimes millions of years, just to arrive at this very moment. The light from our closest stellar neighbor, Proxima Centauri, takes a little over 4 years to reach us. This means that when you look up at that star, you're seeing it not as it is now, but as it was 4 years ago. The universe has built-in delays, gentle pauses between moments, as if time itself is taking slow, deep breaths. And our own star, the Sun, speaks to us in whispers of light that take 8 minutes and 20 seconds to cross the space between us. Right now, the light warming the day side of Earth left the Sun's surface just 8 minutes ago. It's almost like a letter sent across the solar system, arriving with perfect timing, never early, never late. The Sun has been sending these letters every moment for 4.5 billion years, patient and constant. Speaking of patience, there's something wonderfully soothing about the way our moon drifts. Each year, the moon moves about 3.5 centimeters farther away from Earth. It's been doing this since it formed, slowly, gradually, in no particular hurry. Billions of years from now, it will be much farther than it is tonight, but for now, it's right where it needs to be, keeping our planet steady, creating the tides, reflecting the sun's gentle light back to us in the darkness. The moon's gravity pulls at Earth's oceans, creating a rhythm, high tide, low tide, high tide, low tide, a cosmic breathing that has continued for eons. And here's something remarkable, this dance between Earth and Moon has actually been slowing down Earth's rotation, making our days gradually longer. When Earth first formed, a day was only about 6 hours long. Now it's 24. The universe has been giving us more time, little by little, every single day that passes. Let that settle in for a moment. Time itself has been expanding for us, stretching out, giving us more hours to rest, to dream, to simply be. And in this vastness, in all this patient cosmic choreography, here's perhaps the most calming fact of all: you are made of stardust. The atoms in your body, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, were forged in the hearts of ancient stars that lived and died billions of years ago. Those stars collapsed and scattered their elements across space, and eventually, those same atoms came together to form Earth, and you. You are literally made from the cosmos itself, and one day, those atoms will return to space and become part of new stars, new planets, new stories. You're not separate from the universe. You're woven into it, part of its endless, gentle cycle. Now that you know you're made of starlight, let's float a little deeper into the velvet darkness of space, where silence reigns and everything moves with such grace. There's something profoundly peaceful about the nature of space itself. If you could float out there, beyond Earth's atmosphere, you would experience the most complete silence imaginable. Sound needs air to travel, molecules bumping into molecules, creating waves. But space is nearly empty, a vacuum so quiet that no explosion, no stellar wind, no cosmic event makes a sound. Out there, the universe unfolds in perfect, absolute silence. All the drama of supernovas, colliding galaxies, stars being born, it all happens without a whisper. The cosmos keeps its secrets quiet. And speaking of stars being born, this is happening right now, even as you rest here. In the Orion Nebula, visible to the naked eye on winter nights as a fuzzy patch in Orion's sword, new stars are forming in clouds of gas and dust. These stellar nurseries are gentle places, where gravity slowly, patiently pulls material together over hundreds of thousands of years. There's no rush. A star knows it is all the time in the universe. The nebula glows with soft colors, pinks and blues and purples, like a cosmic watercolor painting, and within it, baby stars are taking their first breaths of fusion, learning to shine. Here's something that might ease your mind: the universe is not chaotic. It follows rules, patterns, rhythms. The planets in our solar system orbit the sun in nearly circular paths, each one keeping to its lane, moving at just the right speed to neither fall into the sun nor drift away. Earth completes its journey around the sun every 365.25 days, so reliable that we set our calendars by it. Mars takes 687 days. Jupiter takes nearly 12 years. Everything is precisely choreographed, a celestial ballet that has been performing without error for billions of years. And the planets themselves, they're so much quieter than you might think. Venus, our closest planetary neighbor, spins so slowly that one day on Venus, one complete rotation, takes 243 Earth days. Imagine a sunrise that takes months to complete, the sun barely moving across the sky, everything happening in the slowest of slow motion. Time on Venus is thick like honey, unhurried, dreamlike. Even more soothing, Saturn's rings. Those magnificent bands of ice and rock that circle the planet aren't solid, they're made of countless individual particles, some as small as grains of sand, others as large as houses, each one orbiting Saturn at its own pace. The rings are only about 30 feet thick in most places, thin as paper compared to their width. If you could stand on one of those ice particles, you'd be surrounded by trillions of neighbors, all of you floating together in a slow procession around the giant, golden planet below. The rings even cast gentle shadows on Saturn's clouds, creating soft bands of darkness that drift across the planet's surface. But here's what truly makes the cosmos a place of rest: the distances. Everything in space is so far apart that collisions are incredibly rare. Our solar system is mostly empty space. If the sun were the size of a basketball here on Earth, the nearest star would be in Australia. Galaxies can pass through each other, billions of stars interpenetrating, and yet the odds of any two stars actually colliding are virtually zero. The universe has given everything room to breathe, room to exist without crowding, without pressure. Even when galaxies do merge, and our Milky Way will one day gently merge with the Andromeda Galaxy, it happens so slowly, over such vast timescales, that any civilizations present would barely notice. The stars would simply weave past each other like dancers, finding new patterns, new configurations, all in the slowest waltz imaginable. You see, the universe is patient. It doesn't rush. And neither should you. Let yourself sink deeper now, like settling into the softest pillow in the universe, and let's travel to a place where time almost stops entirely. Out beyond Neptune, in the frozen reaches of our solar system, there exists a realm called the Kuiper Belt. Here, millions of icy objects drift in the darkness, so far from the sun that sunlight arrives as barely more than a bright star in the black. These objects, chunks of ice and rock left over from when the planets formed, take hundreds of years to complete a single orbit. Some of them haven't made even one full trip around the sun since humans learned to write. They move through space like sleepers who never wake, undisturbed, unchanged, perfectly preserved in the cosmic deep freeze where temperatures hover around -400 degrees Fahrenheit. Time moves differently out there. Everything is still. And speaking of cold, here's something wonderfully calming: the universe itself is cooling down. The entire cosmos has a temperature, and right now, it's about 2.7 degrees above absolute zero, that's -270 degrees Celsius. This is the afterglow of the Big Bang, called the cosmic microwave background radiation, a faint warmth that fills all of space. It's like the universe is wrapped in the softest, thinnest blanket, the last remnants of its fiery birth now cooled to almost nothing. Every year, every century, every millennium, the universe grows just a tiny bit cooler, a tiny bit calmer, settling into its long, slow evening. This gentle cooling is happening everywhere, all at once. If you could see in microwave wavelengths, you'd see the entire sky glowing with this faint, nearly uniform warmth. Scientists have measured it with extraordinary precision, and they've found that it's almost exactly the same temperature in every direction, varying by only a few 10,000ths of a degree across the entire observable universe. The cosmos is remarkably smooth, remarkably even, like a perfectly calm sea stretching out in all directions. Now let's visit Jupiter for a moment, because Jupiter has a secret that might ease you into even deeper rest. On this giant planet, there's a storm called the Great Red Spot, an enormous hurricane larger than Earth itself. And this storm has been raging for at least 400 years, possibly much longer. When Galileo first pointed his telescope at Jupiter in 1610, this storm might have already been ancient. It simply swirls and swirls, a vast oval of churning clouds in shades of red and orange and cream, persisting year after year, century after century, with no sign of stopping. There's something oddly comforting about that, a storm that doesn't end, that just continues, steady and eternal, following the same patterns it has followed for longer than any human has been alive. And here's another gentle truth about our solar system: there are no sharp edges. Everything fades gradually. Earth's atmosphere doesn't suddenly stop at some definite height, it just gets thinner and thinner, fading imperceptibly into the vacuum of space. The sun's influence doesn't end abruptly either. Its solar wind, a constant stream of particles flowing outward, extends far beyond the planets, growing weaker and weaker until, somewhere past Pluto, it finally mingles with the gentle breeze of particles from other stars. Even our solar system's boundary is soft, blurred, like watercolors bleeding into each other. Speaking of the solar wind, the sun breathes out constantly, releasing about 1 million tons of matter per second into space. But the sun is so massive, containing 99.8% of all the mass in our entire solar system, that it can sustain this for billions of years without even noticing. It's been breathing like this for 4.5 billion years, and it will continue for another 5 billion more. The sun's breath washes over Earth constantly, creating shimmering curtains of light near the poles, the aurora borealis and aurora australis, soft greens and pinks and purples dancing in the night sky. The universe painting with light while you sleep. Everything flows. Everything breathes. Even stars. Let that rhythm match your own breathing now, in and out, slow and steady. You're floating now, weightless in the cosmic ocean, and it's time to discover just how gentle gravity can be. Imagine standing on the surface of Pluto, that distant, heart-shaped world at the edge of our solar system. Gravity there is so weak, just 6% of Earth's gravity, that if you jumped, you would hang in the air for several long, peaceful seconds before drifting slowly back down to the icy surface. Everything would feel lighter. A person who weighs 150 pounds on Earth would weigh only 9 pounds on Pluto. You could move in slow motion, each step a gentle bound, each movement effortless and dreamlike. The sun from Pluto would appear as nothing more than an exceptionally bright star, casting a twilight glow across frozen plains of nitrogen ice. It's a world of perpetual dusk, quiet and still. And Pluto has a companion, its moon Charon, so large compared to Pluto itself that the two are sometimes called a double planet. Here's what makes them special: they're tidally locked to each other, meaning the same side of Pluto always faces Charon, and the same side of Charon always faces Pluto. If you stood on the right spot on Pluto's surface, Charon would hang motionless in your sky, never rising, never setting, just hovering there forever in the exact same position. The two worlds dance together, face to face, for all eternity. They've been looking at each other for billions of years, and they'll continue for billions more. Now, let's drift outward to the stars themselves, because stars have life cycles just like everything else, and most of that life is spent in the most peaceful phase imaginable. Our sun is what astronomers call a main sequence star. It's in the long, stable middle of its life, fusing hydrogen into helium in its core. This phase lasts about 10 billion years. The sun is currently about halfway through, which means it has been shining steadily for 4.6 billion years and will continue to shine just as steadily for another 5 billion. That's stability beyond human comprehension. Every morning for billions of years, the sun has risen. Every evening, it has set. Nothing rushed. Nothing hurried. And our sun is just one of an estimated 200 to 400 billion stars in the Milky Way galaxy. Picture that for a moment: hundreds of billions of suns, each one a nuclear furnace, each one burning with patient, steady light. The Milky Way itself is a vast spiral, rotating so slowly that our sun takes about 225 million years to complete one orbit around the galactic center. The last time our solar system was in this exact position in the galaxy, dinosaurs were just beginning to walk the Earth. We're on a cosmic Ferris wheel that moves so gradually, you'd never notice the motion. Here's something else to ease your mind: most of the universe is empty space. The atoms that make up your body, the atoms that make up everything you can see and touch, they're mostly empty too. If you could remove all the empty space from all the atoms and all the humans on Earth, the entire human race would fit into a volume about the size of a sugar cube. We're almost entirely emptiness held together by invisible forces. You are mostly space, mostly silence, mostly the same nothingness that fills the cosmos. In a way, the boundary between you and the universe is an illusion. You're more continuous with the void than you might think. And in that void between stars, between galaxies, there's something invisible that holds everything together: dark matter. We can't see it, we can't touch it, but we know it's there because of how it affects the things we can see. Dark matter makes up about 85% of all matter in the universe, and it forms a kind of cosmic scaffolding, a gentle web that cradles galaxies and keeps them from flying apart. It's everywhere, passing through you right now, countless particles streaming through your body every second without you ever noticing. The universe is held together by invisible threads, by forces we're only beginning to understand, and somehow that makes it feel even more mysterious, even more magical, even more like a dream. Let yourself dissolve into that mystery now, becoming lighter, more space than substance, drifting. Breathe with the universe now, slow and deep, and let's travel to places where light itself becomes something gentle, something you can almost touch. There are clouds in space, not the fluffy white clouds of Earth's sky, but enormous stellar nurseries made of gas and dust, stretching across light years. The pillars of creation, in the Eagle Nebula, are perhaps the most famous. These towering columns of cosmic dust are so vast that if you started at the bottom of one pillar and traveled at the speed of light, it would take you about 4 years to reach the top. Inside these pillars, hidden from view, new stars are quietly forming, wrapped in cocoons of dust, taking their time. The pillars themselves are slowly evaporating, sculpted by the radiation from nearby young stars, dissolving like ice sculptures in the sun, except this process takes millions of years. The universe creates, and then gently, patiently erases, and then creates again. And here's a thought to carry you deeper into rest. The light you see from distant stars and galaxies has never been seen before and will never be seen again. Every photon that enters your eye has been traveling for years, centuries, even millions of years, crossing incomprehensible distances, and of all the possible paths it could have taken through the universe, of all the places it could have gone, it found its way to you. In this very moment. And once your eye absorbs it, that photon's journey ends. Each glance at the night sky is a completely unique moment in cosmic history. You are witnessing light that is ancient, precious, and utterly unrepeatable. Now let's visit Neptune, the most distant planet in our solar system, a world of the deepest, most beautiful blue. Neptune is so far from the Sun that it receives 900 times less sunlight than Earth does. Despite this, Neptune has the strongest winds in the entire solar system, howling at speeds up to 1,200 miles per hour. But here's the mystery: where does the energy for these winds come from? Neptune actually radiates more heat into space than it receives from the Sun. The planet has its own internal furnace, warming itself from within, generating its own weather from some deep core of heat left over from its formation billions of years ago. It's a world that creates its own energy, its own storms, independent of the Sun. Even in the coldest, most distant reaches of our solar system, there's warmth, there's movement, there's life of a kind. Speaking of warmth, let's talk about red dwarf stars. These are the smallest, coolest, and most common type of star in the universe, making up about 75% of all stars. A red dwarf burns so slowly, so efficiently, that it can live for trillions of years, far longer than the current age of the universe itself. The universe is only 13.8 billion years old, but red dwarf stars will still be shining when the universe is thousands of times older. Not a single red dwarf that has ever been born has yet died. They're the tortoises of the stellar world, patient, enduring, burning with a dim, steady glow that will outlast everything else. When all the other stars have exhausted their fuel and faded, red dwarfs will still be there, quietly illuminating a much older, much darker cosmos. And here's something that connects the very large to the very small. Every atom in your body has been on an extraordinary journey. The hydrogen atoms in your body, the ones in the water that makes up most of your cells, those atoms were created in the Big Bang itself, 13.8 billion years ago. They're among the oldest things in existence. The heavier elements, like the carbon in your DNA and the iron in your blood, were forged in stars that exploded as supernovas, scattering their contents across space. Then those atoms drifted through interstellar clouds for millions of years, eventually coming together in the disk of gas and dust that would become our solar system. They were part of the early Earth, cycling through oceans and rocks and atmosphere, through countless organisms over billions of years, and finally, they became part of you. You are ancient. You are recycled stardust. You are the universe looking at itself. And the journey doesn't end with you. One day, far in the future, those atoms will return to the Earth, and then perhaps back into space, to be part of new worlds, new stars, new stories yet unwritten. Everything is borrowed. Everything returns. Nothing is ever truly lost. Let yourself become weightless now, drifting through the cosmic dark where time loses all meaning. There's a place in space where time itself slows down. Near a black hole, gravity becomes so intense that it warps the very fabric of space-time. If you could somehow safely orbit close to a black hole's event horizon and then return to Earth, you would find that far more time had passed here than you experienced there. Hours for you might be years for everyone else. Einstein showed us that time is not a constant ticking clock, it's flexible, malleable, flowing at different rates depending on where you are and how fast you're moving. Time near a black hole moves like honey, thick and slow, while time far away rushes past like a river. The universe has different speeds, different rhythms, and right now, lying here, your time is your own. And black holes, despite their fearsome reputation, are perhaps the universe's greatest teachers of patience. When matter falls into a black hole, from our perspective watching from far away, it appears to slow down as it approaches the event horizon, taking longer and longer, until it seems to freeze at the boundary, caught in an eternal moment. The light from that falling matter gets stretched out, redder and redder, dimmer and dimmer, but never quite disappearing. In a way, nothing ever truly falls into a black hole from our point of view, it just fades, slowly, approaching but never quite reaching that final boundary. Even the most violent cosmic events unfold with infinite patience when seen from the right perspective. Let's drift now to Miranda, one of the strangest moons orbiting Uranus. Miranda's surface is a patchwork of terrains that look like they don't belong together, smooth plains next to jagged cliffs, some of which tower 12 miles high. That's nearly twice the height of Mount Everest. But here's the remarkable part, on Miranda, gravity is so weak that if you accidentally walked off one of those towering cliffs, you'd fall in slow motion, taking about 10 minutes to reach the bottom. 10 minutes of gentle falling, drifting down through the silence, watching the icy surface slowly approach. It would be terrifying, yes, but also strangely peaceful, enough time to think, to observe, to simply be present in that long descent. Now, let's think about the nature of darkness itself, because darkness is not empty. The night sky appears black to us, but that's only because our eyes can't see most of what's there. If you could see in infrared, the darkness would glow with the heat of distant galaxies and cooling stars. If you could see in radio waves, the sky would be alive with the whispers of pulsars and the echoes of cosmic events. If you could see in X-rays, you'd witness the violent beauty of matter swirling around black holes. The darkness is full of light we cannot see, full of messages we cannot hear, full of wonders beyond our senses. Even in what appears to be emptiness, the universe is singing. And speaking of singing, there's a moon in our solar system that hums. Enceladus, a small icy moon of Saturn, has geysers at its south pole that shoot water ice and vapor hundreds of miles into space. These geysers are fed by a vast ocean hidden beneath the moon's frozen crust, an ocean that's kept liquid by tidal heating, the gravitational squeeze and release as Enceladus orbits Saturn. Scientists have discovered that this ocean contains the basic ingredients for life: liquid water, organic compounds, and energy sources. Somewhere beneath the ice of a distant moon, there might be warm underwater currents, mineral-rich ocean floors, perhaps even something living. The universe might be more full of life than we ever imagined, thriving in hidden oceans, in sheltered places, in the quiet spaces between worlds. Here's a final thought for this part of our journey. The Voyager 1 spacecraft, launched in 1977, is now the most distant human-made object in existence. It has traveled beyond the influence of the Sun, into interstellar space, more than 15 billion miles from Earth. And it's still sending signals back to us, faint whispers of data that take more than 22 hours to reach home, traveling at the speed of light. Voyager carries a golden record with sounds and images from Earth, greetings in 55 languages, music from different cultures, the sound of rain, of waves, of a human heartbeat. It's a message in a bottle, cast into the cosmic ocean, saying we are here, we existed, we reached out into the dark. And it will drift through space for billions of years, long after humanity is gone, a testament to our curiosity, our hope, our desire to connect with something beyond ourselves. You too are sending ripples out into the universe, just by being here, just by existing. Rest now in that knowing. You're deep in the dream now, floating through the velvet cosmos, and it's time to discover the gentlest motions in all of creation. There are galaxies out there that move through space like dancers in an endless ballet. Our Milky Way and the Andromeda Galaxy are slowly approaching each other at about 250,000 miles per hour. That sounds fast, but they're so far apart, about 2.5 million light-years, that they won't begin to merge for another 4 billion years. 4 billion years of gradual approach, slowly spiraling toward each other through the darkness. When they finally do meet, they won't collide violently. Instead, they'll pass through each other like two clouds of fireflies, their stars weaving together in an intricate dance that will take another billion years to complete. The result will be a new galaxy, larger and more beautiful, sometimes called Melkometa. Everything in the universe moves toward union, toward connection, but always gently, always with time to spare. And here's something to ease any worries you might carry. Statistically speaking, you are living in the safest time in Earth's history. Our planet has been struck by asteroids in the past. The one that ended the age of dinosaurs was 6 miles wide, but today, astronomers catalog and track every large object that comes anywhere near Earth. The solar system has mostly cleared itself out over billions of years. The chaos of the early solar system, when planets were still forming and debris filled the space between worlds, has settled into calm, predictable orbits. You are living in the quiet era, the stable time, when Earth glides peacefully through space on its well-worn path around the Sun. Let's visit Titan now, Saturn's largest moon, a world that's strangely familiar and alien all at once. Titan is the only moon in our solar system with a thick atmosphere, thicker than Earth's, in fact. If you stood on Titan's surface, the atmospheric pressure would feel similar to being 15 feet underwater on Earth, noticeable, but not crushing. The sky would be a hazy orange, and methane rain would occasionally fall from clouds, filling lakes and rivers with liquid hydrocarbons. Titan has weather, seasons, a hydrological cycle just like Earth's, except instead of water, it's methane and ethane. Scientists believe that the conditions on Titan might resemble those on early Earth, before life began. It's a world frozen in time, showing us what our own planet might have looked like 4 billion years ago, waiting patiently for whatever comes next. Now let me tell you about the cosmic web, one of the most beautiful structures in the universe. Galaxies aren't scattered randomly through space, they're connected by vast filaments of dark matter and gas, forming a web-like pattern that spans the entire observable universe. These filaments, stretching across hundreds of millions of light-years, are like the threads of a cosmic tapestry, and at the intersections of these threads, you find clusters of galaxies. The voids between the filaments are vast and nearly empty, containing very few galaxies at all. From far enough away, the universe looks less like scattered points of light and more like a delicate lace, an intricate network connecting everything to everything else. We're all part of this web, our galaxy connected by invisible threads to galaxies we'll never see, all of us hanging together in the same cosmic net. Here's something wonderfully intimate. When you look up at the stars on a clear night, some of that light is being bent by gravity as it travels to you. Massive objects like galaxies can act as gravitational lenses, warping the fabric of space around them, bending light from more distant objects behind them. Sometimes this creates multiple images of the same distant galaxy, or stretches it into beautiful arcs and rings called Einstein rings. The universe is not just expanding outward, it's folding in on itself, creating funhouse mirrors in the fabric of reality. Light doesn't always travel in straight lines. Even light takes the scenic route sometimes, curving around massive objects, exploring the landscape of spacetime before finally arriving at your eye. And perhaps most soothing of all, meteors. When you see a shooting star streak across the night sky, you're watching a tiny piece of cosmic dust, often no bigger than a grain of sand, burn up in Earth's atmosphere. These particles have been drifting through space for millions or even billions of years, slowly orbiting the Sun, until finally their path intersects with Earth. In that brief moment of friction with our atmosphere, they heat up and glow, creating a flash of light that lasts only a second or two. It's a little goodbye from the cosmos, a particle that has traveled for eons across the solar system, and its final act is to give you one brief moment of beauty before it vanishes. Every shooting star is a tiny ceremony, an ending and a gift, all at once. Wishes cast into the cosmic dark, each one heard, each one held. Sink deeper now, deeper than sleep, into the oldest memories of the universe. There was a time, very early in the universe's history, when everything was dark. After the Big Bang, the universe was too hot for atoms to form, it was just a glowing soup of particles and radiation. But then, about 380,000 years after the beginning, the universe had expanded and cooled enough for the first atoms to come together. Electrons and protons joined to form hydrogen, and suddenly the universe became transparent. Light could finally travel freely. This moment is called recombination, and the light from that era is what we now detect as the cosmic microwave background radiation. But after that initial glow faded, the universe entered what astronomers call the Dark Ages, a period lasting hundreds of millions of years when no stars had yet formed. The universe was filled with neutral hydrogen gas, dark and quiet, waiting. Just waiting. In silence. In patience. Until finally, gravity began its slow work, pulling that gas together, and the very first stars ignited, tiny points of light in an ocean of darkness. The universe learned to shine. Those first stars were different from the sun. They were massive, perhaps 100 times more massive than our star, and they burned blue-white and incredibly hot. But they lived fast and died young, exploding as supernovas after only a few million years. When they exploded, they scattered the first heavy elements into space: carbon, oxygen, iron, the building blocks of planets and life. Every subsequent generation of stars was enriched by the ashes of those ancient giants. We are the descendants of those first stars, children of their light and their sacrifice. Let's travel now to one of the most serene places in our solar system, the Lagrange points. These are special locations in space where the gravitational pull of two large bodies, like the Earth and the Moon, or the Earth and the Sun, perfectly balances out. If you placed a spacecraft at one of these points, it would stay there, floating in perfect equilibrium, neither pulled toward one body nor the other. The James Webb Space Telescope orbits one of these points, called L2, about 1 million miles from Earth. It's a place of perfect stillness, where the telescope can observe the universe without being disturbed by Earth's heat or light. These Lagrange points are like cosmic parking spaces, peaceful harbors in the gravitational currents of the solar system. Here's something about the Moon that might ease you into even deeper rest. It's gradually slowing Earth's rotation, but it's also stabilizing our planet. Without the Moon, Earth would wobble chaotically on its axis like a spinning top running out of momentum. This wobbling would cause wild swings in climate. The poles might sometimes point toward the sun, then away, creating extreme seasonal variations. But the Moon acts like a gyroscope, keeping Earth's tilt steady at about 23.5 degrees. This stable tilt gives us regular, predictable seasons. Spring always follows winter. Summer always follows spring. The Moon is Earth's anchor, keeping us steady, keeping us safe, keeping everything in rhythm. And speaking of rhythm, pulsars are perhaps the most precise timekeepers in the universe. These are rapidly spinning neutron stars, the collapsed cores of massive stars after they've exploded. Some pulsars rotate hundreds of times per second, and as they spin, they emit beams of radiation from their magnetic poles. If one of those beams sweeps past Earth, we detect it as a pulse, like a cosmic lighthouse. The most stable pulsars keep time more accurately than atomic clocks. They spin with such regularity that astronomers can predict their pulses years in advance, accurate to within millionths of a second. The universe has heartbeats, steady and unwavering, ticking away the eons with perfect precision. Now, think about this. The atoms in your left hand might have come from a different star than the atoms in your right hand. When the cloud of gas and dust that formed our solar system came together, it was mixed from the remnants of multiple supernovas, each one contributing different elements. The iron in your blood might have been forged in a star that exploded on one side of the galaxy, while the calcium in your bones came from a star on the other side. You are a mosaic, a gathering of stardust from across space and time, billions of years of cosmic history assembled into one single, unique being. You are a collection of ancient light, pressed together into human form. And all of it, all of these atoms, are mostly just space. Empty space. Held together by forces we can barely comprehend. You are the universe, dreaming itself into existence. You're dissolving now into the cosmic stillness, becoming part of the endless quiet, and there are places in the universe where peace has reigned unchanged for billions of years. Consider the Oort cloud, a vast spherical shell of icy objects surrounding our solar system, extending almost halfway to the nearest star. It begins about 2,000 times farther from the Sun than Earth is, and stretches outward for nearly a light year. Out there, in that distant frontier, trillions of comets drift in the cold and dark, barely moving, taking millions of years to complete even a fraction of their orbit. The Sun is just a bright point of light, no larger than other stars. Time has almost stopped. Nothing disturbs the silence. These objects have floated there, virtually unchanged, since the solar system formed 4.6 billion years ago. They are witnesses to everything that has happened: the formation of planets, the evolution of life on Earth, the rise and fall of countless species, and yet they remain untouched, pristine, sleeping in the dark. And here's a truth that connects us to the farthest reaches of space: we are all moving together. Right now, as you lie here, you're not just spinning with Earth's rotation at about 1,000 miles per hour at the equator. You're also orbiting the Sun at 67,000 miles per hour. The Sun itself is carrying us around the center of the Milky Way at 514,000 miles per hour. And the entire Milky Way galaxy is moving through space at about 1.3 million miles per hour, pulled by the gravity of distant galaxy clusters. Yet you feel none of this motion. Everything moves together, in concert, like a grand cosmic symphony where every instrument plays in perfect harmony. You are traveling through the universe at extraordinary speeds, but from your perspective, all is still. All is calm. Let's rest for a moment on Mars, the red planet, Earth's quieter sibling. Mars has the largest volcano in the entire solar system, Olympus Mons, a shield volcano so vast that it covers an area roughly the size of Arizona. It rises 16 miles above the Martian surface, nearly 3 times the height of Mount Everest. But here's the beautiful part: Olympus Mons is so gently sloped that if you stood at its base and looked up, you wouldn't even realize you were at the foot of a mountain. The slope is only about 5 degrees. You could walk up its flanks and barely notice you were climbing. After hours of walking, you'd eventually reach the summit and look back to see the curve of Mars falling away beneath you. It's a mountain so massive that its grandeur can only be appreciated from space, so gentle in its rise that standing on it feels like standing on flat ground. There's something profoundly peaceful about the concept of heat death, the distant future of the universe. In trillions upon trillions of years, all the stars will have exhausted their fuel. Black holes will have evaporated through Hawking radiation. The universe will reach a state of maximum entropy, where everything is spread evenly throughout space at the same temperature, just barely above absolute zero. No energy will flow, no events will occur, nothing will change. It will be the ultimate rest, the ultimate stillness. The universe will have found its final equilibrium, settling into an eternal, unchanging peace. It's so far in the future that it's almost beyond imagination, but there's something comforting in knowing that eventually, even the cosmos itself will rest. But before that distant ending, there will be such wonders. About 5 billion years from now, when our sun begins to die, it will swell into a red giant, growing so large that it might engulf Mercury, Venus, and possibly Earth. But it won't explode. Our sun isn't massive enough for that. Instead, it will gently shed its outer layers in slow, beautiful pulses, creating a planetary nebula, a glowing shell of gas expanding outward into space. At the center will remain the Sun's core, compressed into a white dwarf no larger than Earth but incredibly dense. That white dwarf will shine with leftover heat for billions of years, slowly cooling, slowly fading, like an ember from a fire that has already gone out. It will be the Sun's long goodbye, graceful and gradual. And even now, in this present moment, there are stars in the night sky that have already died. Their light is still traveling to us across the vastness of space, but the stars themselves have already ended their lives. Some collapsed into white dwarfs, others exploded as supernovas, their remnants scattered across light years. We're seeing ghosts, the afterimages of suns that no longer exist. The past and present blur together in the night sky. When you look up, you're not seeing the universe as it is now, you're seeing a collection of different moments from history, all arriving at your eyes at the same instant. The cosmos is a tapestry woven from different threads of time. And you are part of that tapestry, a single thread, glowing briefly, beautifully. Let go completely now, surrender to the infinite, and drift with me to the places where wonder lives in its quietest form. There are moons in our solar system covered entirely in ice, their surfaces smooth and bright, reflecting the dim sunlight like mirrors. Europa, one of Jupiter's moons, has an icy crust that's constantly being renewed, resurfaced by the ocean beneath. The ice is crisscrossed with reddish-brown streaks, cracks where water has welled up from below and refrozen. Scientists believe Europa's ice shell is about 10 to 15 miles thick, and beneath it lies a global ocean containing twice as much water as all of Earth's oceans combined. That ocean has been liquid for billions of years, warmed by tidal forces from Jupiter's immense gravity. Down there, in the absolute darkness beneath the ice, warmed by hydrothermal vents on the ocean floor, there might be life. Not intelligent life, perhaps, but something, microbes, strange organisms adapted to the lightless deep, drifting in currents that have flowed for longer than complex life has existed on Earth. The universe might be filled with hidden oceans, secret sanctuaries where life quietly persists. Here's something to carry with you into sleep: color in space is gentler than we imagine. When you see those vibrant images of nebulae, brilliant reds, electric blues, luminous greens, those colors have been enhanced. To the naked eye, even through a telescope, most nebulae appear as faint, ghostly wisps of gray and white. The colors are real, but they're so dim that our eyes can't perceive them. Only long-exposure photographs and cameras can gather enough light to reveal the subtle hues. The universe is painted in watercolors, not oils, delicate, understated, requiring patience to see. There's a quiet beauty in that, in knowing that the cosmos doesn't shout its colors but whispers them. Let's visit the South Pole of the Moon, one of the strangest places in the solar system. There are craters there, deep and ancient, whose floors have been in permanent shadow for billions of years. The sun has never shone on them, not once in all of lunar history. Inside these eternally dark craters, temperatures drop to -400 degrees Fahrenheit, among the coldest places in the entire solar system. And because nothing ever warms them, these craters have become cold traps, preserving water ice and other volatile materials that would evaporate anywhere else. It's like the moon has freezers, natural storage vaults that have been keeping records of the early solar system for eons. In the perpetual twilight of the lunar poles, where the sun schemes just along the horizon, time stands still. Now, imagine a galaxy so far away that its light has taken most of the age of the universe to reach us. The light we're receiving from some of the most distant galaxies left them when the universe was less than 1 billion years old, just a child, cosmically speaking. We're seeing those galaxies not as they are now, but as they were 13 billion years ago. Those galaxies have continued to live and evolve all this time while their light has been traveling toward us. By now, many of those galaxies have likely merged with others, their stars redistributed, their shapes transformed. The galaxy we observe is a memory, a photograph from the universe's youth. We can never know what those galaxies look like today. Their present moment is forever beyond our reach, hidden behind the speed of light. The universe keeps its current state secret from us, showing us only its past. And here's a gentle mystery: slow-motion spirals. Spiral galaxies like our Milky Way have beautiful, graceful arms sweeping out from their centers, but these arms aren't solid structures. They're density waves, regions where stars and gas bunch up temporarily as they orbit the galactic center. Individual stars drift in and out of the spiral arms over millions of years, but the arms themselves persist, rotating slowly like the blades of a cosmic pinwheel. It's similar to how traffic jams on a highway can move backward even though individual cars are moving forward. The pattern is real, but it's not made of permanent matter. It's a wave, or rhythm, a temporary gathering that creates the illusion of structure. Even galaxies are more fluid than solid, more dense than architecture. Finally, consider this: every second, about 400 billion neutrinos from the Sun pass through every square inch of your body. Neutrinos are ghostly particles with almost no mass, barely interacting with matter at all. They stream out from the Sun's core, where fusion is happening right now, and they pass through the entire Sun, through space, through Earth, through you, as if you weren't even there. You are constantly, every moment, being flooded with particles from the heart of the Sun. The Sun touches you in ways you cannot feel, passes through you in ways you cannot sense. You are transparent to the universe, and the universe is transparent to you. The boundary between inside and outside dissolves. There is no separation, only light, passing through light. You are almost formless now, a consciousness floating in the dark, and the universe has one more secret to share with you about the nature of belonging. There is a place in space called the local bubble, a cavity in the interstellar medium about 1,000 light-years across, and we live inside it. This bubble was carved out by ancient supernova explosions that occurred millions of years ago, clearing away the dense gas and dust and leaving behind a region of hot, thin plasma. We're floating inside this cosmic hollow, surrounded by the remnants of stellar explosions that happened long before humans existed. The bubble's walls are made of denser material where new stars are forming even now. In a way, we live in a clearing in the forest, a quiet space sheltered by the very violence that created it. Even destruction gives birth to sanctuary. And speaking of shelters, Earth has an invisible shield protecting it every moment. Our planet's magnetic field extends tens of thousands of miles into space, creating a teardrop-shaped bubble called the magnetosphere. This field deflects most of the solar wind, that constant stream of charged particles from the Sun, sending it flowing around Earth like water around a stone in a stream. Without this magnetic shield, the solar wind would gradually strip away our atmosphere, the way it stripped away most of Mars's atmosphere billions of years ago. But Earth's liquid iron core, churning and convecting deep beneath your feet, generates this protective cocoon. The planet is holding you, keeping you safe every second of every day. You are cradled in invisible arms. Let's drift to the moons of Saturn, particularly one called Iapetus, a world painted in two colors. One hemisphere of Iapetus is bright, icy white, while the other is dark as coal. The boundary between these regions is sharp, creating a yin-yang pattern visible from space. Scientists believe the dark material comes from dust swept up as Iapetus orbits through Saturn's system, accumulating on the leading hemisphere. Once darkened, that side absorbs more sunlight, warming slightly, which causes more ice to evaporate, leaving behind even more dark material, a gentle feedback loop that has been operating for billions of years. Iapetus wears the evidence of its long journey through space on its very surface. Here's something about time that might ease any urgency you feel. On a cosmic scale, a human lifetime is immeasurably brief, but that doesn't make it less significant. Consider that the light from the sun takes 8 minutes to reach Earth. In that same 8 minutes, light from the most distant galaxies we can observe would travel only a tiny, infinitesimal fraction of the distance it needs to cross. Those galaxies are so far away that their light has been traveling for over 13 billion years. In comparison, 8 minutes is nothing. A human life of 80 years is nothing. And yet, that light from distant galaxies, after all its traveling, after crossing most of the observable universe, finds its purpose in a single moment when it enters a human eye and is seen. 13 billion years of journey, completed in an instant of perception. Your brief moment of consciousness gives meaning to eons of cosmic history. You are not insignificant. You are the universe becoming aware of itself, even if only for a heartbeat. There's a phenomenon called cosmic dawn, the period when the first light from the first stars began to spread through the universe, ending the dark ages. This happened gradually, over hundreds of millions of years, as more and more stars ignited. Slowly, bubble by bubble, region by region, the universe transitioned from darkness to light. It wasn't a sudden switch, it was a gentle awakening, like a sunrise that took a billion years. The universe didn't rush into illumination. It took its time, allowing light to spread naturally, organically, at its own pace. And even now, in our own galaxy, stars continue to be born at a rate of about 1 or 2 new stars per year. The Milky Way is still creating, still making new light. In stellar nurseries like the Orion Nebula, in the dark clouds of the Carina Nebula, hydrogen collapses under its own gravity, heats up, and ignites. Right now, somewhere in our galaxy, a new star is taking its first breath. Another one will be born tomorrow. And the day after that. The universe hasn't stopped creating. It continues, patiently, steadily, bringing new lights into existence, one at a time. You too are a light, briefly kindled, but burning nonetheless. And when your light eventually fades, the atoms that made you will scatter, and become part of new creations, new stories, new lights. Nothing ends, everything transforms. You are barely here now, almost entirely dissolved into the cosmic whole, and in this final passage, let the universe whisper its deepest truths about endings and beginnings. There is a concept in physics called the observable universe, the sphere of space from which light has had time to reach us since the Big Bang. It extends about 46.5 billion light-years in every direction, creating a sphere with us at the center. But here's the gentle truth, we are not actually at the center. Every observer, everywhere in the universe, sees themselves at the center of their own observable sphere. A being on a planet in a galaxy 10 billion light-years away would see a completely different set of galaxies around them, with themselves at the center of their own horizon. Everyone is at the center. No one is at the edge. The universe has no privileged position, no special location. Wherever you are home. You belong exactly where you find yourself. And beyond our observable universe, beyond that horizon, the universe continues, perhaps forever. There are galaxies we will never see, stars whose light will never reach us because the expansion of space is carrying them away faster than light can travel. Those galaxies exist in a space forever separate from ours, unreachable, unknowable. The universe is larger than perception, deeper than observation. Most of reality remains hidden, and that's perfectly all right. We don't need to see everything to appreciate the beauty of what we can see. Let's rest now in the rings of Saturn one last time, because they teach us about impermanence. Those magnificent rings, the most beautiful structures in our solar system, are temporary. They're relatively young, perhaps only 100 million years old, created when a moon or comet came too close and was torn apart by Saturn's gravity. And they won't last forever. The rings are slowly raining down onto Saturn, pulled by gravity, particles spiraling inward. In another 100 million years, they may be gone entirely. Saturn will be ringless again, the way it was for most of its existence. Beauty doesn't need to be eternal to be perfect. The rings exist now, in this narrow window of time, and that's enough. You exist now, in your own narrow window, and that too is enough. There's a place in the universe where time began, though it's not a place you can point to. The Big Bang didn't happen at a location, it happened everywhere at once. Every point in space was present at the beginning, compressed together. When the universe expanded, every point moved away from every other point. Space itself stretched, carrying everything with it. This means that the place where the Big Bang occurred is here. Right where you are. And also there. And everywhere else. You are lying at the birthplace of the universe. The beginning is still with you, still beneath you, still all around you. You have never left home. And here's a final comfort about stars. When a massive star dies in a supernova explosion, scattering its elements into space, those elements don't simply drift away and disappear. They join the interstellar medium, vast clouds of gas and dust floating between the stars. And eventually, those clouds collapse under their own gravity to form new stars and new planets. The death of one star becomes the birth of others. Nothing is wasted. Nothing is lost. The universe recycles everything, endlessly creating new forms from old materials. Death is not an ending, it's a transformation, a continuation, a passing of the torch from one generation to the next. Consider neutron stars, the collapsed cores of massive stars, packed so densely that a teaspoon of neutron star material would weigh about 1 billion tons on Earth. These objects are only about 12 miles across, smaller than most cities, yet they contain more mass than our entire Sunday. When you compress matter that densely, strange things happen. The surface gravity is so intense that it's almost perfectly smooth. Any mountains higher than a few millimeters would collapse under their own weight. A neutron star is the smoothest object in the universe, polished by gravity into near-perfect spherical symmetry. Even in the aftermath of a violent stellar death, the universe finds its way to peace, to smoothness, to equilibrium. And finally, silence. In the deepest reaches of intergalactic space, far from any stars or galaxies, there is darkness and cold and quiet beyond imagining. No light. No sound. No motion. Just the cosmic microwave background radiation, that faint whisper of the Big Bang, and the slow, patient expansion of space. It's the closest thing to absolute nothingness that exists in our universe. And yet even there, quantum fluctuations are occurring, tiny ripples in the fabric of space-time, virtual particles briefly appearing and disappearing. Even in the emptiest void, the universe is never truly still, never truly silent. There's always something happening, however subtle, however quiet. Just like you, even in your deepest rest, your atoms are vibrating, your cells are working, your heart is beating, soft and steady. You are never truly still, and yet you are at peace. You are the universe, breathing, slowly, gently. Resting, but never stopping. Dreaming of stars. You've rested in the silence, and now we drift onward, deeper into the cosmic night, where even stranger wonders await in the velvet dark. There are storms on Jupiter that are older than human civilization. Beyond the Great Red Spot, there are smaller storms, white ovals and brown barges, some of which have been observed for over a century. These storms don't dissipate the way Earth's hurricanes do because Jupiter has no solid surface for them to encounter. There's nothing to slow them down, nothing to break them apart. They just swirl and swirl in the thick atmosphere, sustained by Jupiter's internal heat and the churning of its clouds. A storm on Jupiter could theoretically last forever, spinning endlessly in bands of cream and rust and gold, a perpetual dance with no final curtain. Let's visit a comet now, those wanderers of the solar system. Comets spend most of their lives in the frozen outer reaches, in the Kuiper belt or the distant Oort cloud, where they're just dark chunks of ice and rock, invisible and dormant. But when a comet's elliptical orbit brings it close to the sun, something magical happens. The sun's warmth begins to vaporize the ice, and the comet grows a glowing halo called a coma, and then long, flowing tails of gas and dust that can stretch for millions of miles. The tail always points away from the sun, pushed by solar wind and radiation pressure. A comet on its way toward the sun has its tail trailing behind, but on the return journey, the tail goes first, leading the way back into the darkness. Comets don't just travel, they transform, blooming as they approach warmth, then fading again as they retreat into cold. They teach us that change is not permanent, that we can become bright and then quiet again, over and over. Here's something about the nature of orbits that brings a deep calm: they are eternal pendulums. When a planet orbits the sun, it's actually falling toward the sun constantly, but moving sideways fast enough that it keeps missing. Earth falls toward the sun every moment of every day, but our sideways motion, our orbital velocity, ensures we fall around the sun instead of into it. We are in a constant state of falling, and yet we never hit the ground. An orbit is a perfect balance between motion and gravity, a harmony that can continue unchanged for billions of years. You too are falling through life, pulled by forces you cannot control, and yet somehow, you keep moving forward, you keep missing the disasters, you keep going around and around, held in balance by invisible forces. Now, think about the moons of the outer solar system, so many of which are icy worlds with hidden oceans. In addition to Europa and Enceladus, there's Ganymede, Jupiter's largest moon and the largest moon in the entire solar system, bigger even than the planet Mercury. Ganymede has its own magnetic field, the only moon known to have one, creating a miniature magnetosphere within Jupiter's much larger one. Beneath Ganymede's ice, there may be an ocean containing more water than all of Earth's surface water combined. Layer upon layer of water and ice, a vast underground sea that has remained liquid for billions of years. The outer solar system is full of secret oceans, hidden beneath frozen shells, quiet and dark and possibly alive with microbial life. The universe keeps its most precious possibilities concealed, protected, waiting to be discovered. There's a beautiful concept in astronomy called the habitable zone, sometimes called the Goldilocks zone, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold. Earth orbits comfortably within the Sun's habitable zone, which extends roughly from Venus's orbit to just beyond Mars. But here's the wonder. Scientists have discovered thousands of exoplanets orbiting other stars, and many of them lie within their own star's habitable zones. Planets where the temperature might allow for oceans, for rain, for life. We now know that potentially habitable worlds are common in the universe. You are not living on the only oasis in a barren cosmos. There may be countless other worlds where the conditions for life are just as gentle, just as perfect as they are here. And those exoplanets, they orbit stars of every type. Some orbit red dwarfs, where the habitable zone is very close to the star. A planet there might be tidally locked, with one side an eternal day and the other an eternal night, and a narrow band between them where the sun hangs forever at the horizon, creating a perpetual sunset. Imagine living in that twilight band, where the sky is always painted in orange and purple, where the sun never rises or sets but glows steadily at the edge of the world. Other worlds, stranger worlds, wait in the darkness between stars. Rest in the knowing that you are not alone in the universe, that somewhere, on some distant world, the conditions might be just as gentle, just as welcoming, just as perfect for consciousness to arise and look up at the stars. Deeper still, into the vastness, where even the familiar becomes strange and beautiful in new ways. There's a phenomenon in space called spaghettification, a term astronomers actually use, and it describes what happens when you fall into a black hole. As you approach the event horizon, the difference in gravitational pull between your head and your feet becomes so extreme that you would be stretched out like a piece of spaghetti, growing longer and thinner. But here's the gentle part, from your own perspective, you wouldn't feel anything unusual. Time would slow down so dramatically near the black hole that everything would seem normal to you, even as the rest of the universe seemed to speed up and fade away. Eventually you'd cross the event horizon, still feeling perfectly fine, while to anyone watching from far away, you'd appear to freeze at the boundary, your light getting redder and dimmer but never quite disappearing. Different perspectives, different realities, both equally true. Let's float to Mercury now. The smallest planet and the closest to the Sun. Mercury has the most eccentric orbit of all the planets, the most elliptical, the least circular. When it's at its closest point to the Sun, called perihelion, Mercury is 29 million miles away. At its farthest point, aphelion, it's 43 million miles away. This variation creates strange effects on Mercury's surface. Because the planet rotates very slowly, taking 59 Earth days to complete one rotation, and because its orbit is so elliptical, there are places on Mercury where the Sun rises, then stops, then moves backward across the sky, then stops again, and finally continues forward. The sun performs a little dance at sunrise and sunset, hesitating, reversing, a cosmic waltz caused by the interplay of Mercury's spin and its changing orbital speed. Even the rising of the sun can be complicated, non-linear, full of unexpected grace. Here's something about cosmic distances that makes the universe feel both vast and intimate. The nearest star system to us, Alpha Centauri, is 4.37 light-years away. The fastest spacecraft humanity has ever built, the Parker Solar Probe, travels at about 430,000 miles per hour. At that speed, it would still take over 6,700 years to reach Alpha Centauri. And yet, if you could fold a piece of paper 42 times, it would reach from Earth to the Moon. If you could fold it 51 times, it would reach the Sun. The exponential nature of doubling creates bridges across impossible distances, at least in theory. The universe plays with scale in ways that defy intuition, collapsing and expanding depending on how you measure. Now, consider brown dwarfs, objects that fall between planets and stars, too massive to be planets but not quite massive enough to sustain hydrogen fusion and become true stars. They're sometimes called failed stars, but that's unfair. Brown dwarfs glow with infrared heat from their formation, slowly cooling over billions of years. They can be quite large, some are 80 times more massive than Jupiter, but they shine with a dim, gentle warmth rather than fierce nuclear fire. They occupy a quiet middle ground, neither star nor planet, existing in their own category. The universe doesn't always fit into neat boxes. Sometimes things exist in the in-between spaces, and that's perfectly valid. There's a type of star called a variable star, whose brightness changes over time. Some variables pulse rhythmically, expanding and contracting like a beating heart, brightening and dimming with perfect regularity. These are called Cepheid variables, and they're incredibly useful to astronomers. There's a direct relationship between how bright a Cepheid is and how fast it pulsates. Brighter Cepheids pulse more slowly, dimmer ones pulse faster. By measuring the pulse rate, astronomers can determine the star's true brightness, and by comparing that to how bright it appears from Earth, they can calculate its distance. These pulsating stars are cosmic lighthouses, their rhythmic beating helping us map the universe. Even the heartbeat of a star has purpose, has meaning, helps us find our way. And speaking of finding our way, spacecraft that travel to the outer solar system need to be incredibly patient. The New Horizons probe, which visited Pluto in 2015, was launched in 2006. It spent 9.5 years crossing the solar system, most of that time in hibernation mode, its systems powered down to conserve energy, just coasting through the void. For nearly a decade, it drifted silently through space, covering billions of miles, waiting for its moment. When it finally reached Pluto, it had just a few hours to gather all its data before speeding past and continuing into the Kuiper Belt. Years of journey for hours of observation. But those hours gave us our first close look at Pluto, revealed its heart-shaped glacier, its towering mountains of water ice, its hazy blue atmosphere. Patience yields wonders. Everything worth seeing requires waiting, requires trust, requires letting time unfold at its own pace. You are adrift now in the deep currents of space and time, and the universe has more gentle secrets to share about the nature of light and shadow. There are places in our solar system where sunlight has never fallen, not in 4.5 billion years. deep inside certain craters on Mercury, despite being the closest planet to the Sun, permanent shadows exist where temperatures remain cold enough to trap water ice. The Sun never rises high enough in Mercury's sky to peer into these crater floors. They are pockets of eternal night on a world scorched by daylight, frozen sanctuaries just a few miles away from sun-baked plains hot enough to melt lead. The universe creates contrasts, extremes living side by side, heat and cold existing in the same small world. Let's think about the asteroid belt now, that region between Mars and Jupiter where millions of rocky fragments orbit the Sun. In movies, asteroid belts are depicted as dense, chaotic fields where collisions are constant. But the reality is far more peaceful. The asteroid belt is mostly empty space. If you were standing on one asteroid, the next nearest asteroid would likely be hundreds of thousands of miles away, appearing as nothing more than a faint point of light. You could fly a spacecraft through the asteroid belt with your eyes closed and have almost no chance of hitting anything. Even in what we call a belt, the universe preserves enormous distances, enormous silence, enormous room to breathe. Here's something beautiful about the way planets formed: they grew from dust. In the early solar system, tiny particles of dust and ice drifted in orbit around the young sun. Sometimes these particles would bump into each other and stick together, just barely, held by weak electrostatic forces. Over millions of years, dust grains became pebbles. Pebbles became rocks. Rocks became boulders. Boulders became mountains. Mountains became planetesimals, and planetesimals eventually became planets. Everything started small. Everything started gentle. Earth wasn't born in a cataclysmic instant, it accumulated grain by grain, impact by impact, over tens of millions of years. You too are an accumulation, built slowly, experience by experience, moment by moment, into the person you are now. There's a star called Betelgeuse in the constellation Orion, a red supergiant so enormous that if you placed it where our Sun is, its surface would extend past the orbit of Mars. Betelgeuse is approaching the end of its life. It could explode as a supernova at any time, astronomically speaking. Any time might mean tomorrow, or it might mean 100,000 years from now. We simply don't know. When it does explode, it will briefly outshine the entire galaxy and be visible from Earth even during the day, as bright as the moon. But Betelgeuse is 650 light-years away, which means that the light we're seeing from it right now left the star in the year 1375. If Betelgeuse exploded today, we wouldn't know about it for another 650 years. The star might already be gone, its dramatic death already occurred, and we're still seeing its ghost, its past, its memory shining in the winter sky. The universe is full of delayed revelations, truths that haven't reached us yet. And speaking of supernovas, when a massive star explodes, it doesn't just destroy, it creates. In the incredible temperatures and pressures of a supernova, elements heavier than iron are forged: gold, platinum, uranium. Every atom of gold in every ring, every necklace, every electronic device on Earth was created in the heart of an exploding star and then scattered across space. Gold is supernova dust. When you hold something made of gold, you're holding the compressed heart of a stellar explosion, a fragment of the most violent events in the universe, now quiet and solid and beautiful in your hand. Even destruction creates treasures. Now let's rest on Mars again, but this time, let's think about its moons, Phobos and Deimos, fear and dread, named after the companions of the Greek god of war. These are tiny moons, irregularly shaped, probably captured asteroids. Phobos is so close to Mars that it orbits the planet 3 times per day. It rises in the west and sets in the east, moving so fast across the Martian sky that it crosses from horizon to horizon in just 4 hours. And Phobos is gradually spiraling inward, getting closer to Mars by about 6 feet every century. In 50 million years, it will either crash into Mars or break apart into a ring system. Even moons have expiration dates, but they're measured in millions of years. Nothing in the cosmos is permanent, but everything lasts long enough. Everything has its season. Close your eyes and feel yourself orbiting, spiraling slowly, held in balance, for exactly as long as you need to be. You're floating deeper into the cosmic ocean now, where even stranger beauties wait in the darkness, where the universe reveals its most patient processes. There's a type of object in space called a protoplanetary disk, a flat, spinning disk of gas and dust surrounding a young star. Our solar system began as one of these disks 4.6 billion years ago, and we can see them around newly formed stars throughout the galaxy. These disks are nurseries, wombs where planets are slowly being born. The dust particles drift and collide, stick and separate, gradually coalescing into larger bodies over millions of years. If you could watch a protoplanetary disk in time-lapse, sped up 1 billion times, you'd see streams and spirals of material, gaps being carved by forming planets, a graceful choreography of matter organizing itself into worlds. Creation is rarely sudden. Creation is almost always a slow, patient gathering. Let's visit a pulsar up close, in your imagination, because the reality is too strange for simple description. Remember, a pulsar is a neutron star that spins rapidly, sometimes hundreds of times per second, sweeping beams of radiation across space like a lighthouse. The fastest known pulsar, called PSR J1748-2446 AD, rotates 716 times per second. That means its surface is moving at nearly 1/4 the speed of light. A mountain on this star, if such a thing could exist, would be experiencing forces millions of times stronger than anything on Earth, and time dilation would mean that clocks on the surface would tick noticeably slower than clocks in orbit around it. At these extreme rotations, the very nature of space and time becomes twisted, stretched, incomprehensible. And yet the pulsar spins on, steady and precise, its rotation so regular that astronomers can predict its pulses years into the future with extraordinary accuracy. Even in extremity, there is rhythm. Even in chaos, there is pattern. Here's something to help you feel connected across vast distances: radio waves. When you listen to a radio, you're detecting electromagnetic waves that travel at the speed of light. But radio waves don't just come from Earth-based transmitters. The cosmos is full of radio emissions, from the Sun, from Jupiter's magnetosphere, from the centers of galaxies, from pulsars. Radio telescopes can pick up these natural cosmic broadcasts. In fact, some of the static you hear between stations on an old analog radio is cosmic microwave background radiation, the afterglow of the Big Bang itself, turned into sound. When you hear that hiss, you're listening to the echo of creation, the oldest sound in the universe, reaching across 13.8 billion years to touch your ears. Now think about the concept of orbital resonance, a beautiful harmony that exists between some moons and planets. Jupiter's moons Io, Europa, and Ganymede are locked in what's called a 1:2:4 resonance. For every one orbit Ganymede makes around Jupiter, Europa makes exactly 2, and Io makes exactly 4. They're synchronized, like musical notes in a chord, their gravitational influences reinforcing each other in a stable, repeating pattern. This resonance has existed for billions of years and will likely continue for billions more. The universe composes symphonies with gravity, creating harmonies that echo through the solar system. There are galaxies that are colliding right now, but colliding is perhaps the wrong word. When two galaxies merge, as we mentioned before, their stars almost never actually hit each other. Instead, the galaxies pass through each other like two swarms of fireflies, their shapes warping and stretching from gravitational interactions. Over hundreds of millions of years, they spiral around each other, losing angular momentum, gradually settling into a new configuration. Computer simulations show these mergers creating beautiful, temporary shapes, bridges of stars connecting the two galaxies, long tidal tails streaming out into space. The antennae galaxies, visible through telescopes, are caught in mid-merger, their collision creating two long streamers of stars and gas that extend hundreds of thousands of light-years into space, resembling the antennae of an insect. Even galaxies in collision create art. And here's a thought about home. Earth is the only planet we know of where you can stand on the surface and see a total solar eclipse. This is an extraordinary coincidence. The sun is 400 times wider than the moon, but it's also 400 times farther away, which means they appear almost exactly the same size in our sky. During a total solar eclipse, the moon covers the sun so perfectly that you can see the sun's corona, its outer atmosphere, glowing around the moon's dark disk like a halo. This won't always be true. The moon is slowly drifting away from Earth, and in about 600 million years, it will be too far away to completely cover the sun. Total solar eclipses are a temporary gift, existing only during this brief window of cosmic history when the sizes align just right. You are living in the era of perfect eclipses. How fortunate! Rest in this moment, this particular arrangement of planets and moons and light, this exact configuration that will never exist again. We drift onward, through the silent spaces, where the universe keeps its most delicate secrets. There's a beautiful truth about the speed of light. It's not just the speed at which light travels, it's the speed of causality itself, the maximum speed at which any information or influence can propagate through the universe. Nothing can travel faster than light, which means that when something happens in space, its effects spread outward at exactly 186,282 miles per second, creating an expanding sphere of influence. This speed limit creates a natural buffer, a gentle delay between cause and effect. When a supernova explodes 1,000 light-years away, its light takes 1,000 years to reach us. For those 1,000 years, we remain peacefully unaware. The universe has built-in pauses, moments of grace between events, ensuring that nothing changes too suddenly, that every revelation arrives in its own time. Let's think about Venus again, but differently. Venus rotates so slowly that its day is longer than its year. One complete rotation takes 243 Earth days, but one orbit around the Sun takes only 225 Earth days. This means that if you stood on Venus and watched the Sun, through the thick clouds, a full day-night cycle would take 117 Earth days. Sunrise to sunrise, 117 days. the sun would creep across the sky so slowly that you could walk faster than it moves. And interestingly, Venus rotates backward compared to most planets, clockwise when viewed from above, which astronomers call retrograde rotation. On Venus, the sun rises in the west and sets in the east. The universe doesn't always follow the rules you'd expect. Sometimes things spin backward, and that's perfectly fine. Here's something about comets that deepens their magic. When they pass close to the sun and develop their magnificent tails, they're actually dying a little bit. Each close pass strips away some of their mass, ice vaporizing, dust being blown away. A comet might make dozens or hundreds of passages through the inner solar system before it's exhausted, reduced to nothing but a dark, inert rock. Some comets have such short orbital periods that we can watch them fade over human timescales. Comet Encke orbits the Sun every 3.3 years, and astronomers have been observing it since 1786. Over the centuries, it has visibly dimmed and weakened. Every display of brilliance comes at a cost, but the comet gives its light anyway, generously, beautifully, until it has nothing left to give. Now, let's visit the concept of a rogue planet, a world that doesn't orbit any star, wandering through interstellar space in complete darkness and cold. These planets were likely ejected from their home solar systems during the chaotic early days of planetary formation, flung into the void by gravitational interactions. Scientists believe there may be billions of rogue planets drifting through the Milky Way, silent and invisible, their surfaces frozen to unimaginable temperatures. And yet, some of these worlds might still have atmospheres, and deep beneath their frozen crusts, heated by radioactive decay and leftover heat from formation, there could be liquid water. A rogue planet might harbor life in underground oceans, ecosystems that have never seen a sun, organisms living by geothermal heat alone. Life doesn't require daylight. Life finds a way even in the darkest, most isolated corners of the cosmos. There's a phenomenon called gravitational microlensing, where a star passes in front of a more distant star from our perspective, and the gravity of the foreground star acts like a lens, briefly magnifying the light from the background star. For a few days or weeks, the distant star appears to brighten, then returns to normal as the alignment passes. By studying these events carefully, astronomers can detect planets orbiting the foreground star, even rogue planets floating alone in space. The gravity of these worlds, though small, is enough to create a tiny, telltale distortion in the magnified light. This is how we find things that emit no light of their own, things that hide in darkness. We watch for the way they bend reality around them, the way they leave subtle fingerprints on the light passing nearby. Sometimes what's invisible can still be known. And speaking of bending reality, the entire shape of the universe might be curved. Space itself might not be flat. Einstein showed us that mass and energy curve the fabric of space-time, and cosmologists wonder if the universe as a whole might have curvature. If the universe is positive curvature, like the surface of a sphere, then traveling in a straight line long enough would eventually bring you back to where you started. If it has negative curvature, like a saddle, space would stretch outward forever in complex, hyperbolic ways. Current measurements suggest the universe is remarkably flat, neither positively nor negatively curved, but we can't be certain. You might be living on the surface of something incomprehensibly vast, something gently curved in dimensions you cannot perceive, floating through geometries your mind cannot quite picture. And that's all right, you don't need to understand everything, to rest in the beauty of it. Let yourself dissolve completely now, into the spaces between atoms, into the quiet places where mystery lives. There are clouds in space made entirely of alcohol. In a region called Sagittarius B2, near the center of our galaxy, there's a vast cloud of gas that contains enough ethyl alcohol to fill 400 trillion pints. That's the same type of alcohol found in beer and wine, floating in space alongside water, ammonia, and other organic molecules. This cloud is also rich in a molecule called ethyl formate, which gives raspberries their flavor and smells like rum. The center of our galaxy, in a sense, tastes like raspberries and smells like rum. The universe has a sense of whimsy, creating vast clouds of molecules that would be familiar to your senses, hanging in space where no one can taste or smell them. Chemistry doesn't care about observers, it creates its compounds regardless, waiting patiently to be discovered. Let's think about the moon's surface, which is covered in a fine powder called regolith, pulverized rock created by billions of years of meteorite impacts. This dust is jagged and sharp at the microscopic level, like tiny shards of glass, because there's no wind or water on the moon to smooth the edges. When Apollo astronauts walked on the moon, they described the regolith as having a distinctive smell when they brought it back into their lunar module. Some said it smelled like gunpowder, others like burnt charcoal. The smell came from chemical reactions between the dust and the oxygen in the module. The moon has a scent, though only humans who've walked there have ever experienced it. Some mysteries require direct contact, personal presence, the touch of actual experience. Here's something gentle about the nature of stars: they're mostly made of empty space, just like everything else. A star is a ball of plasma, ionized gas, held together by gravity. The atoms are so hot that electrons have been stripped away, creating a soup of nuclei and free electrons. But even in this dense environment, most of the volume is empty. The Sun's average density is actually less than that of Earth, about 1.4 times the density of water. If you could scoop up a cubic meter of material from the Sun's interior, ignoring the fact that it would be impossibly hot, it would weigh about 1,400 kilograms. That's dense compared to air, but surprisingly diffuse for something that shines with such brilliance. Stars are mostly nothing, generating everything. Now, imagine the Voyager spacecraft again, but think about what they carry. Both Voyager 1 and Voyager 2 have golden records attached to their sides, phonograph records made of gold-plated copper, containing sounds and images from Earth. The sounds include greetings in 55 languages, the cry of a baby, the song of whales, music from Bach and Beethoven, Chuck Berry, and traditional songs from around the world. The images show mathematical definitions, the structure of DNA, pictures of humans, animals, and landscapes. These records are designed to last for billions of years in the vacuum of space. Long after Earth is gone, long after the Sun has become a white dwarf, these records will still be drifting through the galaxy, carrying traces of humanity into the cosmic dark. We send our voices into the eternal night, hoping someone, someday, might listen. There's a concept called the Great Attractor, a gravitational anomaly that's pulling our galaxy, along with thousands of other galaxies, toward a specific region of space. This attractor lies about 250 million light-years away, in the direction of the constellations Hydra and Centaurus. We can't see it directly because it's hidden behind the plane of the Milky Way. The dust and stars of our own galaxy block the view. But we can measure its effects, the way it tugs on everything around it. Our entire local group of galaxies, including the Milky Way and Andromeda, is drifting toward this mysterious concentration of mass at about 1,000 miles per second. We're all being pulled somewhere, drawn towards something we cannot see, moving together through the darkness like leaves on a cosmic current. And within that current, within all that motion, there's something called the cosmic rest frame, a theoretical frame of reference defined by the cosmic microwave background radiation. In this frame, the universe looks the same in all directions, perfectly isotropic. Earth, however, is moving relative to this rest frame at about 230 miles per second, which creates a slight asymmetry in the background radiation. It's slightly blue shifted in the direction we're moving and slightly red shifted behind us. This motion is the sum of Earth's rotation, its orbit around the Sun, the Sun's orbit around the galaxy, and the galaxy's motion through space. You are moving at hundreds of miles per second right now, carried on multiple overlapping journeys, and yet lying still, you feel nothing. Motion and stillness are the same when everything moves together. Rest in that paradox, moving and still, falling and floating, present and eternal. You are almost formless now, consciousness without boundary, and the universe whispers its oldest stories into the quiet of your being. There are stars so old they formed before the Milky Way even took its current shape. These are called population 2 stars, and some of them are nearly as old as the universe itself, 13 billion years or more. They contain very few heavy elements because they formed from gas that had been enriched by only a few generations of supernovas, unlike our Sun, which is a relative youngster, rich in metals and elements. These ancient stars burn slowly, conservatively, their dim red light a testament to patience and endurance. Some of them have been shining since before Earth existed, since before our solar system was even a cloud of dust. They are the elders of the galaxy, witnesses to epochs we can barely imagine, still burning quietly in the cosmic night. Let's visit Io, Jupiter's innermost large moon, the most volcanically active body in the entire solar system. Io has over 400 active volcanoes, constantly erupting, spewing sulfur and sulfur dioxide hundreds of miles into space. The moon's surface is painted in brilliant yellows, oranges, reds, and blacks, sulfur compounds in various forms, giving it the appearance of a cosmic pizza, as some astronomers have affectionately described it. Io is caught in a gravitational tug-of-war between Jupiter and the other large moons, constantly squeezed and stretched, and this tidal heating keeps its interior molten. The moon is turning itself inside out, over and over, resurfacing itself so quickly that impact craters don't have time to accumulate. Io's surface is perpetually young, constantly renewed, never holding on to scars. Some forms of healing happen through heat, through release, through letting everything flow outward and begin again. Here's something peaceful about the structure of atoms: they're incredibly stable. The atoms in your body, the hydrogen, carbon, nitrogen, oxygen, their nuclei are bound together by the strong nuclear force, one of the fundamental forces of nature. Those bonds are so strong that atoms can persist for billions or even trillions of years without decaying. A hydrogen atom created in the Big Bang 13.8 billion years ago could still exist today, unchanged, identical to how it was at the beginning. Most of what makes you is effectively eternal. The building blocks of your existence have always been here and will always be here, just rearranging themselves into temporary patterns called you for a brief, beautiful moment. Now think about the scale of the cosmic web we discussed earlier, but in terms of time. the filaments of galaxies stretching across hundreds of millions of light years formed over billions of years, shaped by the invisible scaffolding of dark matter. Computer simulations that model the evolution of the universe show these structures growing like frost on a window, gradually crystallizing from the smooth, nearly uniform conditions of the early universe. Tiny fluctuations in density, variations of only 1 part in 100,000, were amplified over cosmic time by gravity, creating the magnificent web we see today. The universe took randomness and created order, took uniformity and created structure, turned simplicity into complexity through nothing but time and gravity. Everything magnificent emerges from patience. There's a moon of Neptune called Triton that orbits backward, retrograde, like Venus's rotation. Triton is the only large moon in the solar system that orbits opposite to its planet's rotation. This tells us something important: Triton wasn't formed alongside Neptune. It was captured, pulled in by Neptune's gravity from somewhere else, possibly the Kuiper belt. And because of its retrograde orbit, Triton is very slowly spiraling inward toward Neptune. In about 3.6 billion years, it will cross what's called the Roche limit, the distance at which Neptune's tidal forces will overcome Triton's own gravity and tear it apart. When that happens, Triton will break into fragments and form a magnificent ring system around Neptune, perhaps even more spectacular than Saturn's current rings. Every ending creates something new. Every destruction births beauty. And speaking of Neptune's future rings, Saturn's rings, as we mentioned, are temporary. But ring systems themselves may be common over cosmic timescales. Mars might have once had rings in its distant past, created when ancient moons broke apart. Earth might develop rings in the far future if our moon were to somehow disintegrate, though that's unlikely given its stable orbit. Rings come and go, decorating planets for a few million years and then fading, only to potentially form again later. The universe adorns itself, then removes the ornaments, then adorns itself again, like someone trying on different jewelry across the eons. You too are adorned temporarily, with consciousness, with memory, with the particular collection of atoms that form your body. And one day those ornaments will be set down, gently, returned to the cosmic wardrobe, to be worn by something else. We've traveled so far together, through time, through space, through the infinite quiet, and now we arrive at the gentlest truths of all. There is a particle that passes through you constantly, barely interacting with matter at all. We mentioned neutrinos before, but let's think about them differently now. A neutrino can pass through a light year of solid lead without being stopped. That's how weakly they interact with the physical world. Trillions upon trillions of them are passing through your body every second from the sun, from distant supernovas, from the Big Bang itself, and you feel nothing. They are ghosts moving through a ghost world, reminding us that most of reality is not solid, not tangible, not even really there in the way we think of presence. You are mostly transparent. The universe passes through you, and you pass through the universe, and the boundary between the two is an illusion we maintain only through habit. Let's rest now in the quietest place we can imagine, the void between galaxy superclusters. These voids are the largest structures in the universe, vast bubbles of near emptiness, hundreds of millions of light years across, containing almost no galaxies, almost no stars, almost nothing at all. If you could float in the center of such a void, you would see darkness in every direction. The nearest galaxy might be 100 million light years away, appearing as nothing more than a faint smudge even through the most powerful telescope. The cosmic microwave background would still be there, that faint whisper of the Big Bang, but otherwise, nothing. Just you and the expanding fabric of spacetime itself. It's the closest the universe comes to true emptiness, and yet even there, dark matter weaves its invisible web, and quantum fluctuations shimmer in the void. Even nothing is something. Here's a final thought about time: there is no now in the universe. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest star, you see it as it was over 4 years ago. Every point of light in the night sky comes from a different moment in the past. Your vision of the universe is not a single snapshot, it's a collage of different times, all assembled into what appears to be now but is actually a collection of different thens. The present moment is not a universal thing. It's local, personal, yours alone. Right here, right now, this breath you're taking, this is the only true now that exists for you. And when you breathe, remember this: the oxygen you inhale was created inside a star that lived and died before our sun even formed. That star fused hydrogen into helium, helium into carbon, carbon into oxygen, until its core was rich with the very element you need to live. Then it exploded, scattering that oxygen into space, where it eventually found its way into Earth's atmosphere, and now into your lungs. Every breath connects you to stellar death, to ancient explosions, to processes that happened billions of years ago in places unimaginably far away. You breathe stardust. You breathe time. You breathe the universe itself. There are so many stars in the observable universe, an estimated 2 trillion galaxies, each containing hundreds of billions of stars. The total number is beyond human comprehension, beyond what numbers can meaningfully convey. And yet each star is individual, unique, burning with its own particular light, living its own particular story. Just as you are unique among all the beings who have ever lived, each star is unique among all the lights that have ever shone. Your particularity is not diminished by the vastness. If anything, the vastness makes your individual existence more precious, more remarkable. In all the infinite configurations of matter across all of space and time, this particular arrangement, you, here, now, has happened only once. And finally, rest in this: the universe doesn't need you to understand it. It doesn't require your comprehension. It simply invites you to exist within it, to be part of its unfolding, to add your small light to the incomprehensible totality. You don't have to solve the mysteries. You don't have to know how it all works. You can simply be. Simply breathe. Simply rest in the knowing that you belong here, in this cosmos, in this moment, exactly as you are. The stars will continue to shine whether you understand them or not. The galaxies will continue to spin whether you observe them or not. The universe will continue to unfold whether you're awake or asleep. And that is the most relaxing truth of all. You can let go. You can rest. You are held by forces you cannot see, guided by laws you don't need to understand, carried on currents that have been flowing since before time began. And in this infinite, ancient, patient cosmos, you are exactly where you need to be. Breathe. Rest. Drift. Sleep. The stars will watch over you. As they always have. As they always will.